Okay, now we're going to talk about theorem 3.36, which is properties of congruence modulo n. So here we have let n be a natural number and a, b, and c be integers. Then for every integer, a is congruent to a mod n. That's called the reflexive property. And if a is congruent to b mod n, then b is congruent to a mod n. That's called the symmetric property. And if a is congruent to b mod n and b is congruent to c mod n, then a is congruent to c mod n. This is called the transitive property. Okay, we're going to prove the reflexive property and the transitive property. The proof of the symmetric property is a homework exercise. So think about the assumptions here. So for number one, there's only one real assumption. It's like a is an integer. Whereas for part C, you've got multiple assumptions. Like you've got this guy, you've got their integers, and you've got this and that. All right. So to prove the first one, we have a very simple assumption that a is an integer. So to show that we want to show that a is congruent to a, well, whenever you're doing something kind of silly, you can use the word notice. So notice that a minus a equals 0 equals n times 0. This proves that n divides a minus a, and hence, by definition of congruence, we've proven that a is congruent to a mod n. All right, that was an easy one. Reflexive property usually is. To prove the transitive property, let n be a natural number, let a, b, and c be integers. We assume that a is congruent to b mod n, and that b is congruent to c mod n. So then, here's another example of your assumption taking up two sentences at the beginning of your proof. We use the definition of congruence modulo n to prove that a is congruent to c mod n. So this is a good way of writing a proof. It's always good to say what you're trying to prove. But when you do that, you want to say things like, we will use the definition to prove. So you're not assuming what you want to prove, because that's bad. Okay. Since a is congruent to b mod n and b is congruent to c mod n, now we got to unpack those. We know that n divides a minus b, n divides b minus c. Hence there exist integers q and k such that this is true and this is true. Then we can add both equations together. If we add them both together and then simplify, so we add them together, simplify, k plus q is the integers, so n divides a minus c, so it's congruent to c. This completes the proof. Okay, so we finished that proof.